This video is about what we call rational equations. Now, before we start talking about rational equations, I want to firstly talk about the word rational. Okay, now, rational in English, just in the normal sense of the word, has a different meaning to what rational means in mathematics. When we talk about rational in English, it means that something makes sense or it's logical, okay? It's got a good reason. That's what we mean when we say that something is rational in English. Okay, now in mathematics, rational means something different. Okay, in maths, rational, if we talk about a number being rational, it means that that number can be expressed as a fraction or as a ratio of two things. So a rational number, is a number that can be expressed as a fraction, okay, or as a ratio of two things. All right, we also have the opposite, which is an irrational number. Okay, so an irrational number cannot be expressed as a fraction. Now, we have discussed this in year 2, but I do want to just quickly go over it. When we talk about irrational numbers, examples of those are things like the square root of 2. Okay, the square root of 2 is a number. It's a real number. We can use it. However, if we try and write it out, we get an unending number of digits after the decimal point. Okay, it goes on forever. So this is what we call an irrational number because we can never write it as a fraction. Okay, another example of this is pi. Okay, pi can also, it also has an unending number of digits after the decimal point. So that is also an unending number of digits that doesn't repeat after the decimal point. That's the key part there. So that is also an irrational number. Another example of an irrational number is the number e, which you will learn about later on. Okay, it's not something you need to worry about right now. Okay, so this is the difference between rational and irrational. So basically, when we're talking about things that are rational, they're things that can be written as a fraction. Okay, now, basically that's most numbers. Okay, for example, 5 can be written as a fraction as 5 over 1. Okay, 2.3 can be written as a fraction as 23 over 10. All right, there's lots of different things like this, and these are all rational numbers. Okay, so a rational equation is obviously an equation that has a fraction in it. Okay, and typically you're going to see that in a ratio table. Okay, so when we have a ratio table and we have something like x over 3 is equal to 12 over 20. Okay, we can use this. This is the same as the fraction x over 3 is equal to 12 over 20. Okay, this is a rational equation. Okay, now when you have this situation, you have plenty of experience with ratio tables. You know that the first thing we always do is we multiply the denominators up. So we multiply by the denominators in order to get them up onto the other side there. Okay, so what we're going to have here is 20x is equal to 12 times 3. Okay, so 20x is equal to 36. And then we can simplify this by dividing both sides by 20. So we get x is equal to 36 over 20. And that simplifies to 9 over 5. Okay, so this is a rational equation. All right, they're not always going to be as easy as this because obviously we like to throw in things where you have proper expressions in the numerator or in the denominator or the numerator. Okay, so for example, you might have something like 5 divided by 2x plus 4 is equal to 1/3. Let's make it nice and easy to start with, and let's see what we get. Okay, so firstly, again, we start by cross multiplying. Okay, and then we're going to get 5 times 3 is equal to 1 times, and always use brackets here, 2x plus 4. Okay, and it's important that you write the brackets, okay? Some people like to just not write them, but then still do it correctly after that, but you're not actually doing the correct thing. Then you must show those brackets when you're writing these out. So we have 15 is equal to 2x plus 4. Okay, we're going to minus 4 from both sides to get the 2x by itself. So then we're going to have 11 is equal to 2x. Okay, our next step then is divide by 2. And we have x is equal to 11 divided by 2, or 5.5. And I don't mind if you leave it as 11 over 2 most of the time. Okay, unless we're doing something with context, 11 over 2 is fine if we just ask you to find x. Alright, so this is an example of a rational equation. Now sometimes you guys might be given examples where you firstly need to move something, okay, but always make sure you have one fraction equal to another before you do the cross multiplying. If you had, for example, let's do the same thing. So let's say we had 5 over 2x plus 4 plus minus 2 is equal to 1/3. Okay, in this case, we don't have a fraction equal to another fraction. So first we need to make sure that this minus 2 goes away. So in this case, we're going to start by adding 2 to both sides. So on the left now, we will have our 5 over 2x plus 4. And that's equal to 1/3 plus 2. Okay, so 2 and 1/3. Okay, now 2 and 1/3, we know we can change it into an improper fraction. Sorry, 2 and 1/3 is equal to 2 3s are 6, so 7 over 3. Okay, so I'm going to change this to 7 over 3. Then we can do our cross multiplying because we have a fraction equal to another fraction. Okay, so here we're going to get 5 times 3 is equal to 7 times 2x plus 4. Okay, 15 is equal to 7 times 2x plus 4. Now in this case, we're not going to divide by the 7 first. We could do 15 divided by 7, but it's going to make it messy. Instead, we will expand the brackets. So 15 is equal to 14x plus 28. Okay, now we're going to minus 28 from both sides. 15 minus 28 gives us minus 13 is equal to 14x. And therefore, when we divide by 14, we end up with x is equal to minus 13 over 14. Okay, so this is how we work with rational equations. But as I said, just make sure you always have a fraction equal to another one before you proceed with this.